In this lecture, we're going to introduce something called sigma notation or summation notation. So this is called sigma notation or summation notation. So the whole idea is that we want to express a sum of integers in a concise way. And this is just an introductory lecture on how to do that, and we'll really be using this in our next chapter on the definite integral. So when we discuss the underlying theory of the definite integral, we'll be needing to sum up a large number of pieces, 1 through n, where n could be any fixed integer. There could be 10 pieces, 100 pieces, 1,000 pieces, and so forth. So instead of writing a sum with 1,000 individual terms, we want a nice notation where we can write all the terms formulaically in a nice single piece. So we're not sitting there forever writing down 1,000 individual terms when there's a nice pattern that will capture the whole thing by itself. So this is how sigma notation works. So it's named after, this is a nice careful drawing of the capital Greek letter sigma. And so we write capital sigma. Lowercase sigma, by the way, looks like this, or it's a little bit like that. So that's lowercase sigma. It's used in statistics as the standard deviation. You might have seen it if you've taken any statistics. So here we have capital sigma, and we say I equals 1 to n of a sub I. So let's analyze the anatomy of what I just wrote down. So first of all, I is called the index or the index of summation. So the whole idea is that we're taking this formula or this guy over here, a sub I, and we're evaluating it for a number of different values of I, and then we're adding them all together. So I is called the index, or the index of summation. So when you see I is equal to something, I is equal to, it says that you're summing over I. So we say that we are summing over I. You would read this as the sum as I goes from 1, so that's down here, to n, and that's the guy up here, of a sub I. The one down here is the starting value. So it's basically the initial value for I. So it's initial value for I. And then the n up here is the terminating value of I, or ending value. And then finally, a sub I is called the summed. So it's the creature that you're summing over. You say that you're summing over a sub I. Okay, so now that we have the anatomy laid out in the nomenclature, let's see what this actually means. So when we say, let me just rewrite it down here. So when we say the sum as I goes from 1 to n of a sub I, what that means is you take this expression and you replace I with 1, just like that, a sub 1. And there's some formula that will tell you what a sub 1 is. You just replace I for 1. And then you add to that a sub 2. And then you add to that a sub 3. And you add to that a sub 4. And you add to that a sub 5. And you keep going until you reach a sub n, and then you stop. So it's a sub 1 plus a sub 2 all the way up to a sub n. So that's exactly what this notation means. This, on the right-hand side, is called the open form, and on the left-hand side, it's called the closed form. So if you're ever asked for a closed form solution, you'd want to express it in sigma notation or summation notation, as opposed to, 1,000 individual terms summed together. So let's take a look at a few examples. That's supposed to be a sigma. I can do better. So sum I equals 1 to 5 of I. All right, so the formula is very straightforward. A sub I is just equal to I. So we replace I with 1 and we get 1. We replace I with 2, we get 2. Then we do plus, replace I with 3, we get 3, plus 4, plus 5, and stop, because 5 is the terminating value right there. So we get 1, plus 2, plus 3, plus 4, plus 5. And that's equal to whatever, 15. Another example, we say, let's do a different index of summation. So let's say j is equal to 1 to 4 of j squared. So in this case, instead of I, we have j, but it's the same game. We replace j with 1, we get 1 squared. We replace j with 2, we get 2 squared. We replace j with 3, we get 3 squared. Replace j with 4, we get 4 squared. Replace j with 5. We don't replace j with 5 because our terminating value is 4 this time. So the sum is 1 squared plus 2 squared plus 3 squared plus 4 squared. And that's, I don't know, 30. Did these very quickly, so hopefully I'm 16 plus 9 is 25, plus 4 is 29, 30. There you go. What about, I'm going to use n this time because sometimes some people use n. N equals 1 to 5 of 1 over n. Okay, so now n is the index of summation. And so we replace n with 1 and we get 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5. So we get 1 plus a half plus a third plus a fourth plus a fifth. And you can find a common denominator and figure out what that's equal to, but that's how it works, just like that. Now let's do something a little bit different. Let's say we have I is equal to 0 to 6 of minus 1 to the I, and then let's say I squared. Okay, so now it's very similar to the second one we have here. It's basically I squared or j squared. So now we have minus 1 to the I. So when we have I is equal to 0, well, first of all, 0 squared is 0. So the first term is just 0. When I is equal to 1, minus 1 to the 1 is minus 1. So we get minus 1 squared. When I is equal to 2, minus 1 squared is plus 1. So we get plus 2 squared. When I is equal to 3, minus 1 cubed is minus 1. So we get minus 3 squared, and then plus 4 squared, minus 5 squared, plus 6 squared. So the whole thing is minus 1 squared, plus 2 squared, minus 3 squared, plus 4 squared, minus 5 squared, plus 6 squared. So minus 1 to the I and minus 1 to the I plus 1 are very useful for creating alternating series. So an alternating series is a series or a sum whose sign alternates from positive to negative. Plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. So you're adding something, subtracting something, adding something, subtracting something. So minus 1 to the I, as we just saw, puts a negative sign on the odd values of I, and then minus 1 to the I plus 1, the negative sign is on the even values of I. So depending on whether or not you want your evens or your odds to be negative, you would use one or the other. So that's a basic tutorial in summation notation and how summation notation works.